All right, so before you watch this video, make sure that you have watched how to evaluate inverse trig functions using the unit circle. Here, I'm just going to talk about using special triangles. So I'm not going to provide any extra explanations like I did in my previous video, so make sure that you're good with those. So I'm going to jump straight to the next page and talk about how we would find the exact values for this inverse sine function. And we're going to do it using our reference or special triangles. All right, so I'm going to draw the two triangles, our special triangles up here. So this will be the pi over 4 one, so 1, 1, root 2. And then over here, I'm going to go pi over 6, pi over 3. So opposite pi over 6 should be 1. This one is root 3, and this one is 2. Okay, so let's get into the first question. We want to figure out sine inverse of 1/2. So remember, that is an angle. So we want to figure out for what angle is sine of that angle equal to 1/2. Well, just by looking at the numbers 1 and 2, that tells us we need to use our 30, 60, 90 triangle to figure it out. And so we want sine theta to be 1/2. So we want to choose the angle where the opposite side is 1 and the hypotenuse is 2. So here's 1 and it's opposite pi over 6. So sine of pi over 6 is 1 over 2. So my theta is pi over 6. And I want to check to make sure that that is the correct answer. So remember, if we're going to use sine inverse, our angle must be between negative pi over 2 and positive pi over 2. This one is, so we're good to go. All right, so they're not all this easy. All right, let's look at another one. Sine inverse of negative root 3 over 2. So I'm trying to figure out what an angle is. So find the angle where sine of theta is root 3 over 2. Well, that tells us, okay, we need to be using this triangle again. We want sine, so we want the opposite side to be root 3, the hypotenuse 2. And so the angle that that works with is pi over 3, opposite hypotenuse. All right, so we're going to go with theta is pi over 3. And this number is also between negative pi over 2 and positive pi over 2. So we are good to go. All right, so let's look at one that's a little trickier. All right, so we got sine inverse of negative 1/2. Again, inverse trig function. We're trying to find our angle theta, such that sine of theta is negative 1/2. So notice our special triangles are all positive. So that means we're going to have to use our quadrants to help us figure this out. So in what quadrants is a sine theta negative? All students take calculus, so sine is positive in both quadrants 1 and 2, and they are it's negative in quadrants 3 and 4. So it's possible that the angle that I'm looking for is going to be in quadrant 3 or quadrant 4. However, we do want to remember that when we're using sine inverse, our angle must be between negative pi over 2 and positive pi over 2. So remember, pi over 2 is up here, negative pi over 2 is here. So we want our angle to be between here and here. So that means whatever we find, it's going to be in the 4th quadrant. Okay, so let's get back to our angle. Since we have a negative, we're going to find our reference angle first. So which angle has a sine theta being 1/2? Well, we found that before. Pi over 6 is our reference angle. All right, and then so what we want to do is put our pi over 6 down here. And so this is the negative direction. So that means that the angle that we're looking for is negative pi over 6. Because it's in the fourth quadrant, and also it is between negative pi over 2 and positive pi over 2. All right, so that is everything for sine. Let's do the same for cosine using our special triangles or our reference triangles. All right, so on the next page we have our cosine. All right, I'm going to rewrite my triangles. Okay, so now remember for cosine inverse, all the angles we're going to find are between 0 and pi. Okay, so let's look here. We're trying to find the angle such that cosine of that angle is root 3 over 2. That tells us exactly which triangle we're going to be using, this one, and we want the adjacent side to be root 3. So that tells us that our angle is pi over 6. And pi over 6 is between 0 and pi, so we're good to go. All right, next, cosine inverse is negative root 2 over 2, so that's our angle. So we want to find the angle such that cosine of that angle is negative root 2, over 2. Notice that we have a negative, so let's go ahead and make sure we know what quadrant it's going to be in. And we're talking about cosine. Cosine is positive in quadrants 1 and 4, so we want it to be negative. So we're looking in quadrants 2 and quadrants 3, but also this angle is only going to be between 0 and pi. This should say pi. So that tells us, oh, actually, we're going to be in quadrant 2. Okay, so let's go ahead and figure out what the angle is going to be. All right, so we want cosine to be root 2 over 2. Well, that tells us we're going to be over here in this special triangle, the 45, 45, 90. All right, so we know cosine and sine are the same. So pi over 4 is our reference angle. It's not our final answer because pi over 4, cosine is going to be positive here. We want it to be negative. All right, so if we draw a pi over 4 in quadrant 2, we can figure out what this angle is, right? We can just take this pi, subtract the pi over 4, and 3 pi over 4 is the angle that we were looking for. Okay, and then finally with our cosine inverse of 1/2, all right, that's our angle theta. All right, so we're trying to find theta such that cosine of theta is 1/2. We're back in our 30, 60, 90. So we want the adjacent side to be 1. So adjacent to 1 is pi over 3. And that is a number between 0 and pi. So we are good to go. All right, and so I'll also include an additional video for a tangent, but this is the gist of how to do this with reference triangles instead of the unit circle.